Hello everyone and thank you for clicking on this link in order to watch my video about my research. Today I'm going to talk about practical work. So hands-on or hands-off? I look into undergraduate life sciences practical work. So the most common answer you get when asking educators about practical work is that there can be no science without hands-on experience and that practical work is what scientists do. Many find it impossible to think about science education without practical work, saying that it is an essential part for effective teaching. So, as someone who has come into this field of education from a biomedical research background, I find myself particularly interested in how best to use hands on science to inform students about scientific ideas. So, what is the problem then? A big part of the literature is concerned with practical work in secondary education, and there has not been enough research on the impact of practical work in the teaching of sciences at university level. Moreover, there is a lack of empirical evidence on how practical work contributes to the understanding of science concepts and motivation during someone's studies. So, apart from being financially more expensive than alternative methods of teaching, practical work requires a lot of time and effort. Financial resources are invested in equipment, consumables, in appointing trained laboratory staff, going through procedures concerning ethical clearance and health and safety. So, all of the above should at least carry advantages that outweigh lecture based science teaching. And in addition, practical work contributes to the increase of tuition fees for international students between degrees of science and those in social sciences, as practical work, as they say, is one of the most costly aspects of science education. So, despite claims that practical work does motivate and contribute in the understanding of science knowledge, as I said before, those claims lack research based evidence. So, critical views emerged showing no evidence of correlation between practical work and science conceptual understanding. So, taking into consideration that for undergraduate students, science is being studied by choice, in contrast to secondary school students who are compulsorily required to study sciences up to the age of 16 in the United Kingdom, it is expected that practical work motivates undergraduates to study sciences, as it has been reported that practical work is one of the most enjoyable aspects of doing sciences. Apart from that, there have been very few studies into the effectiveness of practical work at the university level, and none of them provide support for the suggested purpose, apart from being an important part of the syllabus. However, findings show that the purpose of practical work in secondary school have similar themes with the objectives in the university education, including the development of skills, the development of scientific thinking, affective value, and learning. So there have been three arguments about the effectiveness of practical work, and now I'm presenting you the first. It is argued that practical work promotes understanding of scientific concepts by allowing students to visualize theory. However, there is a big difference between doing a practical activity and understanding it. A practical task without proper guidance can leave students confused, leaving the lab with misconceptions, and this can affect their future learning. So, indeed, studies show that when students were tested using exams, there was no evidence of conceptual understanding, and it will be unrealistic to expect conceptual learning to be directly attributed to solely performing practical tasks. Students understand what they want to understand based on what they have in their mind and based on prior conceptions. So, in comparison to traditional lecture based classes, some studies concerned with undergraduate practical classes reported that practical work was indeed helping them learn, as conceptual understanding was enhanced compared to traditional classes. With regards to the affective argument, uh, it has been said that practical work promotes students' interest in learning science. So, for this reason, it is asserted that interested students will be more involved and focused on the task, and therefore will remember information better. It is unclear, though, whether students find practical activities worthy as a teaching tool or prefer it because it runs in a more relaxed pace and the fact that they do not have to copy from the board. Confirming this, students felt that they had a sense of control over their learning, but this was counterproductive when they started concentrating on non substantial stuff and issues like fixing faulty apparatus. Students also reported that they enjoyed confirmatory experiments, contradicting the true nature of being a scientist, where you use a hypothesis in order to answer your research questions without clear or expected outcomes. In addition to that, students' satisfaction was not increased when more practical work was introduced, as their interest was mainly situational and short term, something that their teachers mistakenly perceives as motivation. With regards to skill, it has been said that practical work helps students in order to develop a good skill set for future employment in the industry. However, a big percentage of STEM graduates do not work in their fields but use their degree related skills into different occupations. So, for this reason, the goal of promoting practical work for enhancing skills is questionable. At the university level, lecturers expose undergraduates to processes and equipment in industrial laboratories. However, it is impossible to expect that students will learn all the machines and all the machines will be the same when they go to a different laboratory and they will have to relearn everything from scratch. At the same time, claims that observation skills are developed with practical work are questionable again, since students need to be in the right conceptual mindset in order to understand what they are seeing, for example, when they're observing something. As a result of the aforementioned findings, a gap has been identified, and this study was conducted to explore the effectiveness of practical work for undergraduates in terms of developing their conceptual understanding and their affective value in the chosen university's School of Life Sciences. The research questions presented today include the first one, talking about whether practical work is effective in helping students build conceptual understanding in life sciences, and whether life sciences practical work has an affective value. So in terms of effectiveness, this research is looking on whether practical work is effective in enabling students learn and do what the lecturer intended, rather than focusing on the effectiveness in general. Only by observing actual laboratories we will be able to see the reality of what is happening in practical classes. So this research is a case study getting an in-depth, detailed understanding of how practical work is being undertaken for year 1 and 2 at the chosen university. It is a mixed methods approach, and the quantitative part involves pre- and post-questionnaires assessing students' expectations of their practical work classes and whether those expectations are fulfilled by doing practical work. Also, a lecturer's activity is given, asking them to put in a ranking order their perceived purpose of practical work for each academic year. For the qualitative part, laboratory observations are made, discussions with undergraduates, and interviews with academic staff. So given the wide variety of practical work, it was decided that effectiveness had to be approached not in general terms, as I said before, but in terms of what the lecturer wants students to do. So in order to do so, this is a model developed by Miller and successfully used by Abrahams and Miller in secondary education, and it was decided to be used in this research. So this model evaluates the effectiveness of a task, and it consists on 2 levels of effectiveness. The lecturer first needs to decide the learning objectives and what undergraduates should learn from the practical task. Then the activity that will enable undergraduates to learn what is intended needs to be decided. The next level of the model takes us to what students actually do, as this might be different from what the lecturer wanted students to do. The last level of this model talks about what students actually learn as a result of their experience during the practical. This is then linked to Tiberghien's model of linking the observables with the domain of ideas, and this will help us identify what do lecturers focus during a practical task. Do they focus on developing scientific knowledge, or do they focus on developing skills? About the affective value, the theoretical framework used was a model introduced by Heady and Renninger. And this 4-phase model of interest development explains that interest influences learning. So interest is triggered by the environment, and it is at first situational. The trigger can either be intrinsic or extrinsic to what the students learn. The situational interest triggers someone into desiring more information about something, in this case answers to the practical lab. The second phase involves persistence and maintenance of interest, and this is affected by instructional conditions and learning environments. This can trigger positive feelings, and through repeated engagement, the interest can emerge. So if situational interest is maintained through effort and interest, then this develops and starts to become personal. Positive attitude, when maintained, contributes to intrinsic motivation. With regards to my preliminary findings, observation data were presented from 6 different practical work lessons with year 1 and year 2 undergraduates. So far, 2 different types of practical work classes emerged. So in Type A classes, students were not given any instruction in the beginning and they were asked to read the protocol and draw possible conclusions. In Type B classes, the lecturer started the session by discussing the main theories and ideas behind the experiment, the objectives and the results students should expect to see, along with explanations and guidelines of what to see. So in Type A practical work sessions, students were mainly focused on hands-on rather than minds-on tasks. So even if some pupils of perhaps higher abilities could understand and recall some theory behind what they were observing, they were unable to interpret their observations when questioned. They were unable to connect observations with ideas without significant prompting from me or the lecturer. The lecturer had to stop them and talk to them about their observations so they could go through the main underlying theories together. Students were effective in the second level of effectiveness. In Type B classes, though, the lecturer introduced the main theories behind the experiment and the ideas students should use to link what they will be observing. This time, students engaged with their observations using the ideas that the lecturer introduced to them. So even if students required help from the lecturer and myself while walking around the laboratory, they could use some scientific ideas in order to explain what they were doing, observing, in order to develop their conceptual understanding. Scaffolding was really important in this part because it helped them link the domain of observables and the domain of ideas, as Tiberghien said, but only when background theory was introduced first. With regards to the lecture interviews, this following conversation was presented. So why do you do practical work? Practical work is important for our students. We're training them to become bench scientists, so we need practical work because that is what scientists do. So do you think practical work is effective? Yes, it is. It helps them remember. We need more practical work, but the university wants to cut it down because it is expensive. So if it is already effective, then why do you need more practical sessions? We want our students to get trained in more techniques so they can understand theory and be qualified when applying for jobs. Repetition builds up skills and creates a momentum for learning. In the last question about whether practical work has an affective value, there were 2 types of answers. So the first lecturer said that yes, it does. It motivates students because they are giving them sufficient training in practical work that can be applied in the clinical sector in the industry later. The second lecturer said that it motivates students who already have an idea of what they want to do in the future, so they actually take advantage of the resources provided. So most of the students were reported to be assessment oriented and they will only turn up to a lab if it was assessed. Preliminary findings from discussions with students had a similar answer when asked from all different classes. Do you understand what you're doing? Do you think that practical work helps you learn? And they said that they see things and this helps them reinforce the theory. Theory makes sense when you see and do things on your own in the laboratory. It becomes more familiar. Even if they do not learn things in detail and sometimes they do not know what they are doing, they will just go home to study and they will recall what they saw in the lab to make sense of the topic and what they did in the practical, as they will remember what they did. So the preliminary conclusions show that practical work offers opportunities to link theory with observations, but Type B sessions were found to be more effective when theory was introduced and main ideas were introduced at the beginning of the practical. So instead of being helped only to observe what the academic staff wants students to observe, it is equally important to scaffold them and help them to think about these observations and link them with the theory in a particular way. Thank you very much for watching this presentation. Please do not hesitate to contact me if you have any more questions or if you want to learn more about my research. Thank you very much.